Clearly visible in the southern sky, the Tarantula Nebula seen here with the Hubble Space Telescope is the largest stellar nursery known in the local universe, a region of intense star formation. But much of the universe is hidden from view, its light being emitted at longer infrared wavelengths. Radiation that can show scientists how stars, solar systems and galaxies were formed and evolved. In Friedrichshafen, on the shores of Lake Constance in southern Germany, engineers in the Astrium cleanrooms have reached a milestone in the construction of the largest ever infrared space observatory. The European Space Agency's Herschel mission is due to launch next year, and the two main parts of the spacecraft have just been assembled.
It's a big event to see the spacecraft together the first time. The only missing part is a telescope and the solar array at this moment. It fitted very nicely. We have to do any adjustments. We just put the cryostat down on the service module and we could put the screws in and it fitted.
The mission follows in the footsteps of ISO, ESA's successful infrared space observatory launched in 1995. But Herschel will observe regions of the infrared spectrum, the far infrared and sub-millimeter, that have never been explored before.
Astronomers want to study the entire electromagnetic spectrum because each part of it tells you something different about the object you study. We will press towards longer wavelengths, towards colder objects in the universe. So we will look into the cradles of star-forming regions. The star forms in big clouds in our galaxy and in other galaxies. These clouds are extremely cold, and when stars form, they are gradually heated up. Now, because we can see the very coldest parts of these clouds, we can study the very early phases of when the stars are forming.
Herschel has a trio of science instruments with unprecedented capabilities in photometry and spectroscopy. They will receive this invisible light from the spacecraft's telescope with its exceptionally large but lightweight mirror made of silicon carbide ceramics.
With 3.5 meters diameter, it is the biggest telescope of its kind. It's not really an optical because it works in far infrared, but it really looks like a real optical telescope and is the biggest massive telescope structure flying. It's one of these fantastic new materials that are ultra stable, very light, and really can work in an environment that is as cold as Herschel, that goes to minus 200 degrees C, without deforming the telescope into fantastic shapes.
The spacecraft's instruments will be kept super cool in the cryostat, a giant thermos flask containing 2,400 litres of slowly evaporating liquid helium, which will keep their detectors at a temperature below minus 271 degrees Celsius.
It works at about half the mass flow of the helium of ISO, so it's in that sense an improved cryogenic system, but it's very, very close. So we really, in this case, build on the heritage of ISO, and clearly you also see the lifetime of the cryostat we have now is about twice the lifetime of ISO, so it will be much longer in orbit to observe.
Herschel will be launched by an Ariane 5 rocket, riding up into space with a sister mission. Under the fairing will also be ESA's Planck satellite to study cosmic microwave background radiation. 4 months after launch, Herschel will be placed at the Lagrangian point number 2, 1.5 million kilometers from Earth, with an unobstructed view of the infrared universe.
There is a whole chemistry going on in these molecular clouds, these clouds in space out of which stars form. And water is one of the prevalent molecules, it turns out. ISO saw water in many places, almost everywhere it looked, actually, when you talk about the interstellar medium. Astronomers in the last 50 or 100 years have discovered that there's much more to the universe than what you can see in light. With Herschel, we are now closing almost the final gap in the electromagnetic spectrum. So when it comes to looking at light, if you like, at all wavelengths, we have almost covered the entire spectrum now.
The 18th century astronomer William Herschel, who discovered infrared radiation, proved that there was indeed much more to light than meets the eye. But he could never have imagined how much ESA's forthcoming space observatory will penetrate the unknown areas of the cold early universe.